patches you see there are actually bonded on special thermal protection, because the real big breakthrough that's needed with rocketry is a truly reusable rocket. You know, if we're to make a revolution in space, it's got to be reusable. If you think about any mode of transport, bicycle, plane,
it's just too expensive to have it disposable.
Exactly. And thus far, it's been an elusive dream in space to create a truly reusable rocket. But that's what we're going to try to do with that. So these are kind of heat tiles for when the stage re-enters to survive the heat of re-entry. So on this flight, we're going to try to recover the first stage, and then later we're going to try to recover both stages. If we can do that, and we can
what would be the key to making sure that
our goal is to make a huge difference in space exploration. Try to make space a lot more like air transport. You know, if you think about it, it's been from 1903 to 1969. From 1903, when the Wright brothers first flew, to 1969, for 66 years. Our first powered flight landing on the moon has been made by Barrack spacecraft, which you may have seen parked on the launch pad there. We'll do the first launch of this big rocket
coming up soon.
Yes.
That's very exciting.
It's a great partnership that we have here between NASA, the Air Force, the FAA, and SpaceX. It's really a great commercial government balance here. The state of Florida as well has pitched in, so it's really made all of this happen very, very quickly.
Right. The Air Force has been really helpful to us. So I do think on the FAA side, just as there is a revolution taking place and a big change taking place in the NASA plans and for commercial spaceflight, that does need to be matched up the FAA on the space side, it isn't currently. I do think that is a critical thing.
Well, that's good to know.
Yeah.
John, FAA, we're going to have to get them involved.
We're going to pick.
Okay, there you go. Have you met John Olvern, my national?
Hi.
National Science Advisor.
Very nice to meet you.
And I'm assuming you know.
Yes, absolutely.
Nice to meet you.
Okay, that's terrific. So was construction actually done here in this factory?
Yes.
Or in this
is where we did the final assembly of the rocket and the spacecraft. So the manufacturing is currently done in California.
Right.
And then we do our testing of the engines in Texas, and then it comes here to the Cape for final assembly.
And this was an old Air Force launch pad, sir, that was accessed over to SpaceX.
Excellent.
Great partnership again to be able to provide them with a great capability and share the land here on a long-term lease.
So what's been the biggest challenge in terms of getting the Falcon going?
Well, the whole rocket's been built from the ground up, so that it's difficult to say that any one particular challenge has been greater than the others, because we've developed the engines, the structures, the avionics, the launch operations, all from scratch, basically. Right. I do think some of the regulatory stuff has been challenging, and that's where I think the biggest need is to make changes.
All right.
Yes, sir. And our number one concern, of course, is public safety. And we've been doing the best we can, but public safety is non-negotiable in some places.
Well, absolutely.
So,
we don't want a rocket landing on anybody's head.
you got it, sir.
Right, and we absolutely agree with that. I mean, our goal is to make a much more reliable vehicle, first of all, and secondly, to make a big improvement in cost.
Now, in terms of use, the idea would be...
I need full set out today.
In terms of use, I think the idea is that this would help to supply the space station.
That's correct. So we were been selected by NASA to perform the cargo transport function that the space shuttle was performing.
Right.
And that decision was made about a year and a half ago.
Right.
It's pretty.
Leslie Woods. Nice to see you, Mr. Woods.
Nice to meet you.
Nice to meet you.
Brian Mostel.
Good to see you, Brian. How are you?
Good
to see you. Well, let's go take a look at the rocket.
All goes according to plan. We'll launch in mid-May. So,
now, how long has this taken?
I did a company called PayPal before that. And,
No, I remember.
Yeah.
But
and then Tesla as well.
No, you must have like a lot of magic on it. got
I'm sort of engineering technology kind of guy. Grew up it is certainly good stream for sure. And I think it's fair to say that this is the most advanced rocket in the world. It's the only rocket that's designed with the patches you see there. It's actually bonded on special thermal protection, because the real big breakthrough that's needed with rocketry is a truly reusable rocket. You know, if we're to make a revolution in space, it's got to be reusable. If you think about any mode of transport, bicycle, plane,
it's just too expensive to have it disposable.
Exactly. And thus far, it's been an elusive dream in space to create a truly reusable rocket, but that's what we're going to try to do with that. So these are kind of heat tiles for when the stage re-enters to survive the heat of re-entry. So on this flight, we're going to try to recover the first stage, and then later we're going to try to recover both stages. If we can do that, and we can
What would be the key to making sure that
in orbit, so there's a full heat shield, a deorbit engines, control during re-entry. We'll also do parachute forward landing, and that'll be kind of the initial phase. And then the later phase will be to have it essentially fly back to the land site, and land on.
You guys, we need to stay ahead.
Yes, I thought much.
Some of the outplaces. I've definitely thought about some of the outplaces.
Once you achieve, you're outside your advantage.
The rocket, basically with the rocket part, is a three-stage rocket. And then a little bit at the top. Yes. So there's a little bit at the top, and then there's basically like a sleeve there. And that section, so the rocket kind of puts that in a parking orbit.
Okay.
And it's about 100 miles below the space station or so.
Okay.
And then that little craft has got its little engines on it, and it maneuvers over to the space station. And yeah.
At this stage it's unmanned, so you're going to
Automated docking and then return to Earth and just land in the water just off the coast of California. Now, when we go to the manned version, the big change is we need a crew escape system. So sort of an escape rockets in case something goes wrong with the booster. And we're going to do something pretty radical there, which is to build the rockets into the spacecraft itself. This is tough.
Yeah, I'm not an engineer, but I can tell that's complicated. But you know, what's wonderful is just seeing the best possible innovation. And obviously, you know, we're going to try to see if we can accelerate this kind of collaboration through put forward. So
It's the right plan.
good. Well, congratulations. This is terrific.
Thank you very much.
How's the car doing?
It's doing great, actually.
Yeah. How do you split your time between car and rocket?
Well, it's usually about 50-50. We should have the sedan on the roads in 2 years. And it'll be the best car on the roads by far. That's our goal.
I'm going to have to test drive it.
Absolutely.
Congratulations. Good luck.
Thanks for helping us open skateboard space.
Absolutely.